if enough ammonium hydroxide were added to 125.0 milliliters of a hydrochloric acid solution with a pH of 3.75 to completely neutralize it, what would be the molarity of the resulting ammonium chloride solution, assuming that the volume remains constant? So in this problem, the first thing I notice is a chemical reaction that I need to check to see if it's balanced. Well, we have one chlorine on each side, one nitrogen on each side. We have 1 plus 4 plus 1, so 6 hydrogens on this side, and 6 hydrogens on that side, and 1 oxygen on both sides. So this is balanced. Now, as I read through the problem, the number that jumps out at me is my pH of 3.75. And there's really only two things we can calculate from a pH. We can calculate a pOH if we're dealing with a base, or a molarity of the hydrogen ion if we're dealing with an acid. Now, even though this problem mentions a base, the ammonium hydroxide, that ammonium hydroxide is there to simply react with the hydrochloric acid. The grammar of the sentence shows that the volume, the pH, are all referring to our hydrochloric acid. So, since we're dealing with an acid, we need to look at converting the pH to a molarity of the hydrogen ion. So that is H plus is 10 to the negative pH. So 10 to the negative 3.75. So 10 to the negative 3.75 gives me 0.00018 molar for my H plus, but since I only have one hydrogen in my hydrochloric acid, it's also the same concentration of hydrogen ions. So, with our molarity of the hydrochloric acid, we can now start calculating a little bit more about our ammonium chloride solution. Now, from this molarity, we can calculate really two things. We can either calculate the moles of hydrochloric acid, or we can go back to pH, which would be very circular, getting us back to the original number and not very helpful. So, we can use our molarity equation. Molarity equals the number of moles divided by liters. So, 0.00018 molar equals the number of moles divided by 0.1250 liters, converting my 125 milliliters into liters before I plug it into the equation. So, solving for number of moles, I would take those two numbers and multiply them by each other to get 2.2 times 10 to the minus 5 moles of HCl. Now, the problem's asking us for ammonium chloride, so I need to do a little stoichiometry here. I can start off with my 2.2 times 10 to the minus 5 moles of HCl. And for our balanced equation, we can see that 1 mole of HCl is equivalent to 1 mole of ammonium chloride, the chemical the question's actually asking about. So, that actually doesn't change my number very much. We end up with 2.2 times 10 to the minus 5 moles of ammonium chloride. Now, to calculate a molarity of that, well, we'll use the same equation we did before. Molarity equals number of moles divided by liters. We have 2.2 times 10 to the minus 5 moles of the ammonium chloride over 0.1250 liters. So if I divide that by 0.1250, I end up back with 1.8 times 10 to the minus 4 molar ammonium chloride, which would be my final answer. And in standard notation, 0.00018 molar. Either form is completely acceptable, since the problem did not state that it needed to be in scientific notation or not.